Welcome to month 2. You survived month 1. You can build Azure functions and connect them to BC. That's huge. But there's a problem we haven't solved yet. What happens when the system you're calling is down? What happens when BC sends data faster than the receiving system can process it? What happens when a message gets lost and nobody knows? In month 1, we build integrations that work when everything works. In month 2, we build integrations that work when things go wrong. And that starts with Azure Service Bus. Service Bus is going to change how you think about integration. Instead of system calling each other directly, they communicate through messages. And that one change makes everything more reliable, more scalable, more resilient. Let me show you what I mean. Your Business Central sends a request through the Azure function to the warehouse or whatever system. The system responds back, everything's happy. And that's how integration works as a simple request. Business Central going forward with something and then getting a response and everything works. Now what happens when Business Central sends something and the warehouse is down, right? Business Central sends something to the Azure function tries to send it to the warehouse, but the warehouse is down. That's the first problem. That order doesn't go through. Maybe someone will remember to retry, but can we really rely on that? The second problem is if a system is slow. Business Central calls the Azure function calls the warehouse, but the warehouse is slow to respond. So what's going to happen here is the Business Central user is either going to get a timeout, or they're going to be locked on the Business Central side waiting for a response to the warehouse, giving a very bad flow. Now there's a third problem. What if the system is overwhelmed? If the warehouse gets too many requests at the same time, the warehouse will become overwhelmed and it cannot respond to Business Central. Either again, you're going to get a timeout, or it's going to tell you too many requests, I can't handle you right now. That is also a problem. This can happen, for example, let's say it's Black Friday and someone like Business Central or another system sends hundreds of orders per minute and the warehouse just can't process them, all of them. What are we going to do here? We cannot lose our orders, right? So that's another problem we need to fix. And the last problem is pretty much like the first one. What if Business Central is down? The warehouse calls our Azure function, but our Azure function tries to call Business Central and Business Central is down. Again, something is going to get lost here. So the warehouse system needs to send inventory updates to BC, but BC is being updated. Maybe it's down for maintenance. Something can happen, right? We're talking about IT. Now what? All of these problems have the same root cause. The systems are too tightly connected. When you call a system directly, you depend on that system being available, fast and ready. That's a lot of assumptions. What if we didn't make those assumptions? So here's a different approach. Instead of BC calling the warehouse system directly, BC puts a message on a queue. That's it. BC job is done. The warehouse system reads the message from the queue when it's ready at its own pace, whenever it wants. The queue sits in the middle and it's the buffer, the shock absorber. The benefit number 1, availability doesn't matter. Warehouse system is down, no problem. Message waits in the queue. When the warehouse system comes back up, the backlog, nothing is lost. Speed difference doesn't matter. BC can send messages as fast as it wants. The queue absorbs them, the warehouse system processes them at whatever speed it can handle, no timeouts, no overwhelm. Decoupling. BC doesn't need to wait for response. Send a message, move on. The user isn't blocked. Processing happens async in the background. Either system can be down. BC is being updated, the warehouse keeps putting messages on the queue. When BC comes back, it catches up. This is called async, loosely coupled integration. The systems don't know each other. They only know about the queue. And that decoupling is incredibly powerful. Before, BC warehouse system, fragile, tightly coupled. After, BC queue warehouse system, resilient, loosely coupled. Same outcome, completely different reliability characteristics. So what is Azure Service Bus specifically? Service Bus is Microsoft's enterprise message broker. It's the queue service in Azure. Highly reliable, highly scalable, built for exactly what we're describing. Let me show the key concepts. If we go to our Azure portal and we search for Service Bus, we have a resource here. And if you try to create a new one, you'll see there are some things we need to know. First off, we have our namespace. It's pretty much like we have our Azure function. It's like our container for all our service buses. Inside our namespaces, we'll have our queues. A queue is a point-to-point, one sender, one receiver. BC sends a message to the queue, one system picks it up and processes it. Topics and subscriptions. For more complex scenarios, you have topics and subscriptions. A topic is published subscriber. One sender, multiple receivers. BC sends a message to a topic, multiple systems can subscribe, and each gets a copy. Order created, maybe the warehouse system needs to know, and the finance system, and the CRM, and the analytics platform. One message, 4 subscribers. So just to phrase this, BC sends something to the queue, and the warehouse takes that from the queue. That's one receiver. If you use a topic, BC makes a topic, and then you have subscriber A is a warehouse, subscriber B is finance, subscriber C is CRM. That's how topics work. For BC integrations, you'll use both. Queues for simple point-to-point, topics when multiple systems care about the same event. Now, there are some different pricing tiers. If you look here, we could try to look at this one. It's a little bit more saying. You've got your basic, standard, and premium. Now, the basic, as you can see, is very cheap. The only problem is, however, as you can see, it does not support topics. It only supports queues. The standard supports topics, which means that this is most probably one you're going to be using the most, depending on what kind of setup you're making. And then we've got the premium. That's really only if you have a lot of messages going out and in. For most cases, you're going to be fine with standard. Or even basic, if you're thinking you're going to have a one-to-one point integration where you don't need more subscribers to the same topic. But let's actually create a service bus. So let's use the same resource group that we already created earlier. So mine is the BC Learning resource group. My namespace, I'm going to say it's going to be BC Learning SB Dennis. SB is of course for service bus. I'm going to place in West Europe. And I am going to take the standard. So let's just review and create. It has validated it. Let's create it. It is created. Let's go to our resource. And up here you can see you have your queue and topics. Let's create a queue. And let's name our queue orders. Let's just leave it for 1 gigabyte. That's more than fine for our learning purposes. And let's leave everything else as it is. So this is how long something will live on our queue before we delete it. 14 days is fine. The lock duration is how long a message is locked before it is being processed. Something we have down here is a dead letter queue. So what is a dead letter queue? Well, it is where messages go when they can't be processed. If a message fails too many times or expires, it goes to the dead letter queue instead of disappearing. You can then investigate what went wrong. This is crucial for production. You never want messages to silently disappear. So let's enable that. And let's create. Now to send and receive messages from our service bus, we need what's called our connection string. Let's go to settings, shared access policies, and we got this root manage shared access key. Let's click on that. And you can see you have some different hidden values. I'm just going to show mine because it's really not that important for me. So you got this one, and this is the connection string itself. So let's copy that. Now, a connection string is like a password. Anyone with it can send and receive messages. In production, you'll create a separate policy with limited permissions. One for senders, one for receivers. For learning, the root key is fine. Let's send some messages. So let's create a Azure function that can trigger this. It's going to be a simple one. In next week, we'll actually do something where you connect it to Business Central. But first, let's just actually call it. Again, let's use Copilot for this. So let's say create a HTTP triggered Azure function that will place a queue. Let's place a message on my service bus queue. Let's get rid of that. Queue. The connection string is this, and my queue name is let's go back. Remember what we call our queue. Let's go to overview. And we have our queue down here. It's called orders, right? So let's say orders. All these stupid pop-ups. Our queue name is orders. And let's just say that the message is going to be something like this. The message we are going to store is this. Just a content type, a message ID. It's going to be a message ID and a subject. Let's see if AI can figure this out. Again, I'm just going to change mine. I don't know. At the time of recording, we just got 4.6 on it. So let's just use that. And let's run it. And it's done. So let's see what it has created. So it has created a new function called place orders. It's HTTP triggered. It takes a payload, subject, order ID. Create some classes down here that is deserializes to. Well, let's just try to keep it. And over here, it has changed. I don't know why it hasn't changed anything on that one, but it has added our service connection bus, right? The string we needed to connect to our service bus. So let's keep that. That's fine. And we have created some new things in our program CS. As you also realize, it also added a NuGet package for our service bus. Let's just keep everything. and it should be up and running. So we've got this new endpoint for our local one. So let's try to check that. Put it inside our postman, create a post, and our AI actually gave us a payload we could try. So let's try to use that. Over here, our body. And let's just try to see what happens when we send this. It returns this. In here, it doesn't give us an error. So now let's try to go back to our Azure portal, go to our queue, go to our Service Bus Explorer, and if we press on the peak next message, you'll see actually here we have our queue, our message on our queue. Perfect. Now let's do something where we can actually also get queues from our message, right? So let's disconnect this. And let's say create a new Azure function that will be triggered by our service bus and pull messages from our orders queue. Let's try to see what happens. So let's see what it has created. It has created this new trigger on orders connection. It uses our service bus connection and service bus trigger, so that's fine. It takes our message, and at the moment it doesn't really do anything with it, but that's fine because it didn't tell it to do anything with it. So let's keep that, and let's try to deploy it. And it says that it has been deployed. So let's go up here and look at our Azure function. And yes, we have got a process order and a place order. Now remember, we are using environmental variables. So we need to take this, go to environmental variables, add a new one, give it that name. And then of course we also need the connection string itself. So let's just copy that. And apply, and confirm. And no, I don't want to save it. So now it should be up and running. And you see different triggers. You have HTTP and you have got the service bus trigger. So if you try to go into this one, it should look pretty much the same as the other one. Now, if we actually go here, now it may take some time before this actually shows up. As it says, first time it can take up to 5 minutes. But on the Azure function, you see it has actually already processed our message queue. So of course, it doesn't really do anything. It just logs some messages here. And if we go back to our service bus, you can also see it's gone from here. So that's actually showing how powerful this is, because when we actually created this message, right, on the message queue, there was no receiver at that point. So even though the receiver actually comes afterwards, it still is managed to get that message. That's showing like if the system was down, it actually retrieves it once it's up and running. So that's pretty cool, right? Just a tip: if for some reason you really want to see this fast and you can't wait those 5 minutes, if you open this in application insights, it will become faster in here. Normally we show pretty fast in here. Contra show out on the log out here. So do you see the pattern? One function sends the message and other function processes them. They don't know each other. They only know about the queue. The sending function could be called BC. The processing function could also call BC or call another system or do anything. It really doesn't matter. Now, if for some reason the message you're sending fails or something like that, it will end up in the dead letter queue. And that's where you then can read it and process it again, or figure out why something went wrong. It might be the payload that's wrong, so the receiving doesn't want that payload, so it will throw an error saying, I don't want that, or something could be wrong. It tries to send it to the same system multiple times, but it cannot receive it. Then it would end in the dead letter queue. Now let me connect this back to Business Central specifically. So scenario 1, order export. BC creates an order. Instead of calling the warehouse system directly, BC sends a message to a queue. Even if the warehouse is down, the order is safe. It'll be processed when the system comes back. Scenario 2, customer sync. Customers create in the CRM. Message goes to a topic, BC subscribers, web shop subscribers, marketing platform subscribers. One event, everyone updated. Scenario 3, batch processing. Need to send 10,000 price updates to an external system. Don't call them one by one. Don't call them, queue them all. Don't call them all one by one. Queue them all. Let them process overnight. A sustainable pace. Scenario 4, external webhooks. External system wants to send data to BC. Instead of calling BC directly, which might be slow or unavailable, the post to your queue and Azure function picks it up and processes it into BC when ready. The next week, we'll build a real BC integration using Service Bus. BC publishing events to a queue, external systems subscribing and reacting. But first, make sure you understand the concepts. Create your namespace, create a queue, send some messages, see how it works. Your homework. Here's your homework for this week. Create a Service Bus namespace. In your learning resource group, use standard tier. Create a queue called orders. Enable dead letter queue on message exploration. Send a message manually from this Azure portal. Here's the Service Bus Explorer feature. Or create a simple sender function. Create a receiver function that triggers on the queue and locks the message. Test failure handling. Make your function fail. Watch the message retry and eventually dead letter. This is fundamental for month 2. Service Bus is the backbone of reliable integration architecture. Next week, we connect it to BC. Messages flowing from BC to queues and from queues into BC. See you then.